Hello everyone, welcome to my YouTube channel Learn Life Science. Myself Vinita Tiwari, and in this particular video I am going to talk about a concept of pH. Okay, so I have designed the lecture with respect to CSIR net examination as well as DBT, ICMR and other life science examination. Okay, so we are going to learn pH from a very simple step to a very complex numericals. Okay, so without wasting any time, let's get started. So, generally we all know that in pH designates the strength of hydrogen ion, okay, the concentration of hydrogen ion in any particular solution. When we talk about acids, it generally denotes a proton or a hydrogen ion. For example, I have given here an acid, that is H. It dissociates, either it will dissociate partially or completely and release a proton group as well as its conjugate base. Okay, for example, acetic acid will dissociate into acetate ion and hydrogen ion. Okay, so this is a proton group, that is hydrogen ion, and an conjugate base, that is an acetate. Okay, so as we know, acid will produce hydrogen ion or H3O plus ions in water. Now, so these are some examples of strong and weak acid. For example, HCl, HNO3, HI, HClO4. Similarly, weak acids में sulphuric acid, H3PO4 and HF. Okay, so these are some common examples that usually we go through in our numericals. Now, so pH generally describes the power of hydrogen ion, the concentration of hydrogen ion in any solution. Okay, it is generally inversely proportional to the hydrogen ion concentration. What does it mean? For example, if any solution contains maximum hydrogen ions, okay, if the concentration of hydrogen ion is maximum in any solution, then the pH will be lower. As we all know, it is a basic that lesser the pH, stronger will be the acidic nature. Okay, so more the concentration of hydrogen ion, lesser will be the pH, okay, and vice versa. Now, we can equate it with pH is equal to the log of 1 by hydrogen ion concentration. Okay, now we are going through a logarithmic relationship. So, by simple step, as we know, log of A by B is equal to log of A minus B. Okay, so simply log of 1 minus log of hydrogen ion concentration. The answer will be 0 minus log of hydrogen ion concentration, because as we know, log of 1 is usually 0. And therefore pH is equal to minus log of hydrogen ion concentration to the base 10. Okay, it doesn't matter where it has stated this base group, that is 10, or it remains either blank. For example, they didn't give the base nature. For example, base to 10 is equal to base to 1. Okay, so don't worry about it. Now moving next, here is a general scale of pH with respect to the hydrogen ion concentration. Okay. For example, each 1 unit change in the pH scale corresponds to a 10-fold change in the hydrogen ion concentration. Now, what does it mean? For example, consider a solution with pH 7. Okay, and you can see here we consider it as a neutral nature, neutral distilled water. Now, for example, you added 10 times acidic solution to this solution of this pH 7. Okay, if you are adding 10 times extra acid to the solution, then it is going to decrease the pH by 1 unit. For example, you can see if you are adding 10 times the acidic solution, it is going to decrease the pH by 1 unit. Okay, similarly, if you are adding 100 times of the acid solution, then it is going to decrease the pH by 2 units. On the other hand, if you are adding 10 times more the basic solution to the neutral distilled water, then it is going to increase the pH by 1 unit. Okay, and if you are adding 100 times the base solution to a neutral solution, then it is going to increase the pH by 2 unit. Okay, you can also take it with other solution. For example, if a solution is having a pH 7 and you are adding 10 times more acid compound to it. If you are adding 10% more solution to it, then it is going to decrease the pH by 1. Okay, for example, it was before it was a pH 5, now it will become pH 4. Okay, so now moving next, what is the ionic product of water? Okay, so in general statement I have mentioned here, for example, a water dissociates into hydrogen ion as well as OH minus ions. Okay, so generally the molarity of water in 1 liter of solution is 55.6 molar. Okay, and when it dissociates, it liberates 10 raised to minus 7 molar hydrogen ion as well as 10 raised to minus 7 molar OH minus ions. Okay, generally we give the ionic product of water by this formula, that is Kw, that is the ionic product, is equal to the product of the product of both the products. Okay, these are the products: hydrogen ion concentration multiplied by OH minus ions concentration. The bracket generally designates the concentration symbol. Okay, simply 10 raised to minus 7 multiplied by 10 raised to minus 7 will give you 10 raised to minus 14. Okay, so when we talk about the ionic product of water, and focus that I have mentioned here at 25 degrees Celsius, the ionic product of water at 25 degrees Celsius is usually 10 raised to minus 14. Okay, now if we calculate the pH of that neutral solution at 25 degrees Celsius, what we will get, minus log of hydrogen and concentration to the base will be equal to minus log of 10 raised to minus 7. Simply what you will have to do here, just take this minus 7 in front. Okay, just separate it. It is a general formula of logarithm. Minus, that is our usual minus, in bracket minus 7 multiplied by log of 10. Minus minus will get into plus, and log of 10 is usually 1. Remember, log of 1 is 0, log of 10 is 1, log of 100 is 2, and so on. Okay, and simply we will get pH of 7. Similarly, you can calculate the OH minus ion OH minus ions strength. Okay, that is the POH. Okay, the same mathematical rule we have applied here. Okay, now moving next. Now what you will get, pH plus POH is equal to 14, and please concentrate right here that I am talking at 25 degrees Celsius. Okay, and as we know, if the condition is acidic, then more hydrogen ion will be present in the solution. If the condition is basic, then more OH minus ions will be present in the solution. Okay, now moving next. I have mentioned here the changes in pH that occurs with respect to the temperature changes. Okay, for example, you can see here at pH 25. Okay, as temperature 25, the pH of a water is 7. Okay, at temperature 25, the pH of water is 7, and its ionic product is 1 into 10 raised to minus 14, as we have already seen. Now, if you increase the pH of the solution, if you increase the temperature of the solution, spontaneously the pH of the solution will also decrease. Okay, the relationship is inverse here. pH is inversely related with the temperature of the solution. If you are increasing the temperature of the solution by heating it, it is obviously going to decrease the pH of solution. Okay, as you can see here, the ionic product is increasing as well as the pH is decreasing. Okay, as at 0 degrees Celsius, you can see the pH is 7.47. Okay, so I hope you understood this table. Now let's talk about monoprotonic acids. Monoprotonic acids are the acids that dissociates and liberates a single proton group or a single hydrogen ion. For example, HCl. HCl is considered as a strong acid because it undergoes 100% dissociation into H plus ion as well as Cl minus ions. Okay, now how you can calculate the pH of a monoprotonic acid? For example, you are questioned that calculate the pH of 0.001 molar HCl. What it means? We can simply go through that 0.001 means simply 10 raised to minus 3 molar. Okay, as we know 0.1 means 10 raised to minus 1, 0.01 means 10 raised to minus 2, and 0.001 will be 10 raised to minus 3. Okay. Now, as we have seen, the formula of pH is equal to the negative log of hydrogen and concentration to the base 10. Okay, or you can say that pH is equal to the log of hydrogen and concentration only. Okay, there is no necessity that you are adding here the base 10. Okay, now consider the solution. As we know, HCl is a strong acid. It is going to liberate 10 raised to minus 3 hydrogen ions as well as 10 raised to minus 3 chlorine ions. Okay, now we want to calculate the pH. Okay, and for the pH you should know the hydrogen ion concentration. Okay, and now we are knowing the hydrogen ion concentration of the strong acid, that is 10 raised to minus 3. Okay, so simply adding it to the formula, that is minus log of hydrogen ion concentration, that is minus log of 10 raised to minus 3. Okay, just simply take this minus 3 in front, that you will get minus in the bracket minus 3 into log of 10. As we know, log of 10 is 1, minus 3 into 1 will be minus 3, and minus minus sign will be cancelled and the answer will be 3. Okay, whenever we are calculating the pH, always remember whatever is the solution, you will have to focus on the hydrogen ion concentration. If you properly estimate the concentration of hydrogen ion in a solution, then you are going to get the correct answer. Okay. Now moving on the next thing, that is, for example, strong acid diluted 100 times. Okay. For example, a strong acid solution is diluted 100 times. What will be the pH of the solution? Okay. So, as I have already told you, if you are diluting the solution, the pH is going to increase, okay, by 2 unit. Okay, I'm sorry, I have not mentioned the pH here. The pH of the strong acid is 4. Okay, the pH of the strong acid is 4. Okay, for example, a solution of strong acid having pH 4 is diluted to 100 times. What will be the pH of the diluted solution? Now, simply you can get the answer. If you are diluting the solution by H2O, it is obviously going to add OH minus groups. On the other hand, you can say that if you are adding water to the solution, it is going to increase the pH. And as I have already told you, if you are diluting the solution by 100 times, the pH will increase by 2 unit, and simply you can get the answer 6. Okay, 4, and the pH initially was 4, and after 100 times dilution, the pH will increase by 2 unit, that is 6. But for you, I have also added here a numerical, that how you can numerically solve it and confirm your answer. Okay, so let's go through it. I have mentioned here the given concepts, that is pH is equal to 4. Okay, if the pH of solution is 4, now you can say that the hydrogen ion concentration in the initial strong acid solution is 10 raised to minus 4. Okay, if you will calculate the pH of 10 raised to minus 4, simply it will get pH 4. Okay, now we are given the concentration of hydrogen ion is 10 raised to minus 4. Okay, and for example, I have taken the volume 1, that is 1 ml. Okay, the initial strong acid solution having 10 raised to minus 4 molar of hydrogen ion and 1 ml volume. Okay, now after the addition of 100 ml water, we want to get the hydrogen ion concentration now for estimating the pH, as well as the volume will get to 100 ml. Okay, now by applying a simple formula, that is C1 V1 is equal to C2 V2, what you will get, just add on the values, and we are considering the unknown concentration of hydrogen ion as X. Okay, so X will be equal to 10 raised to minus 4 divided by 100, or I have written here 10 raised to 2 will be equal to 10 raised to minus 4 minus 2, that is 10 raised to minus 6. Now this is the final concentration of hydrogen ion in the solution. Okay, this is the concentration of hydrogen ion in the diluted solution. Now just add on this value to the pH formula, that is pH is equal to minus log of 10 raised to minus 6. Okay, so simply here minus minus will be cancelled, and 6 into log of 10. As we know, log of 10 is 1. 6 into 1 will be 6. Okay, so it is a simple calculation you can do for your confirmation of the answer. Okay, you can do it easily for your confirmation. Now moving next, let's talk about the pH of multiprotonic acids. Okay, the acids that generally dissociates more than one hydrogen ions or more than one protons. Okay, for example, sulphuric acid, I have taken example, that liberates and releases 2 molecules of hydrogen ions. Okay, as you can see here, the hydrogen ion strength is 2 times more as well as the sulfur group. Now, the important thing on dissociation, what you will get, the concentration of hydrogen ion is 2 times more. Okay, now the concentration of hydrogen ion is 2 times more, as you can see here, as well as the concentration of sulfur group will be same. Okay, that is 0.1. Okay, so in case of multiprotonic acid, you will have to concentrate on the hydrogen ion concentration, and you will also have to focus on the numbers that are present. Okay, if there is H3, okay, if the group is H3, then you will have to focus that the concentration of hydrogen ion will be 3 times more. Okay, now for example, you are given to calculate the pH of a multiprotonic acid, for example sulphuric acid. Okay, its strength is 0.1 molar. Okay, now what will be the condition? H2SO4 on liberation will dissociates 2 hydrogen ion as well as a sulfuric group. Now, initially the concentration was 10 raised to minus 1 molar. After dissociation, what you will get? Now, this is what I was talking about. Initially we were having a concentration of 0.1 molar. Okay, after dissociation, you will have 0.2 molar of hydrogen ion in the solution. Okay, for 0.2, we can also write it as 2 into 10 raised to minus 1. Okay, and the sulfur group will be 0.1 molar, or you can write it in as 10 raised to minus molar. Now, you will have to calculate the pH by taking this concentration of hydrogen ion. Okay, so simply the pH will be equal to minus log of 2 into 10 raised to minus 1. Okay, and on calculation, you will find that log of 2 is 0.3 and you will get the final answer of 0.7. Okay, the important thing to focus right here is that you will have to take properly the concentration of hydrogen ion in case of multiprotonic acid. Okay. Okay, so till now we have learnt about the calculations of pH in case of monoprotonic as well as multiprotonic acid. Now we are switching to the calculation of pH in case of strong bases. Okay, so in case of base, we are going to calculate the POH, okay, the strength of OH minus ions. Okay, so it is going to be equal to the negative logarithm of OH minus ions concentration. Okay, I have also taken a simple question, so let's go through it. For example, you are questioned to calculate the pH of 0.1 molar KOH, or you can say potassium hydroxide. Okay, so you are questioned here to calculate the pH of the solution. Okay, so first we are going to calculate the POH because we are given a base solution. POH will be equal to the negative logarithm of 10 raised to minus 1, and as we know the log of 10 is 1, so the POH will be 1. Okay, now as we have the POH, now we can easily calculate the pH. As we know the pH plus POH is equals to 14, then simply 14 minus 1 will be 13. Okay, so this is the pH of the solution of the KOH solution. Okay, now moving next. Now here you are questioned to calculate the OH minus ions concentration of a 0.1 molar HCl solution. Okay, you are given an a strong acid solution, that is HCl, and you are asked to calculate the OH minus ion concentration. Okay, so if you are given with the acid solution, first you will have to calculate the pH. Okay, now as the concentration is 0.1, that is we can say 10 raised to minus 1, we are simply going to get the pH as 1. Okay, and now you are also going to get easily POH of 13. Simply 14 minus 1 is equal to 13. Now as we have asked to calculate the concentration of OH minus ions, taking the same formula, POH is equal to negative logarithm of the OH minus ions. You are given the POH and taking it as X. Okay, consider it as X. Okay, in this case what you will have to do, you will have to take the antilog. Okay, and you will have to take the antilog, and once you have taken the antilog, what you will get, the OH minus ion concentration is 10 raised to minus 13. Okay, as we know, antilog means what? It will it is going means select any number. For example, you will have to go through a number having a log of 13. Okay, which number is having a log of 13? For example, I have taken here OH minus ion concentration is 10 raised to minus 13. When you will calculate the logarithm of 10 raised to minus 13, you will get the answer 13. Okay, as we have calculated till now. Okay, it is a simple anti-logarithm formulae. Okay, now, so we have estimated the concentration of 10 raised to minus 13. On the other hand, you can calculate the same question with another concept. For example, we are given with the hydrogen ion concentration, that is 0.1 or 10 raised to minus 1. Simply we know the ionic product of water, that is hydrogen ion concentration into OH minus ion concentration, that is equal to 10 raised to minus 14. And simply by cross multiplying, you are going to get 10 raised to minus 13. And I think it is more simpler than this first numerical. Okay, it is a more simple option to go through it. So I hope you understood this till now. Moving next. Now, till now we have calculated the concentration of OH minus ions as well as the pH of a basic solution. Okay, now let's talk about a pH of very dilute solution of strong acid. Okay, for example, till now you are known with the fact that if the hydrogen ion concentration of any solution is 10 raised to minus 3, the pH will be 3. If the concentration of hydrogen ion in the solution is 10 raised to minus 2, the pH is 2. But now, if the concentration of hydrogen ion in any solution is 10 raised to minus 7, it will not mean that the pH of solution is 7. Similarly, if the concentration of hydrogen ion of the solution is 10 raised to minus 8 or 10 raised to minus 9, then it will not mean that the pH of solution is 8 or 9 respectively. Okay, because as we know, the pH of an acidic solution is not going to go greater than 7. Okay, so in such conditions, what you will have to do, you will have to select a pH that is slightly less than 7. Okay, or you can go through a numerical calculation. For example, you will have to calculate the total hydrogen ion concentration in the solution. Okay, the first hydrogen ion concentration due to acid group as well as the other hydrogen ion concentration due to the water. Okay, you will have to calculate the total hydrogen ion concentration, and then you will have to add this concentration to the pH formulae. Okay, so till now I have talked about the concept of pH in case of acid as well as in case of base as well as in case of a very dilute solution. Okay, so please try to solve numericals regarding these topics, and still if you are having any kind of doubt regarding the pH, you can comment in the comment box. Okay, and please subscribe to my channel. My channel is entirely based on life science topic as well as for different competitive life science competitive practices. Okay, so don't forget to subscribe my channel, and if you understood the concept well, do like, share with your friends. Okay, thank you so much for watching the video.